Hey everybody, this is 6.1 set notation and Venn diagrams. On yours it probably says 8.1. I didn't fix that. I got everything else, but I always forget something. All right, so this unit we're talking about probability. And one of the things we can use for probability is doing what's called set notation. It organizes things and it helps us when we want to do probability. So a lot of this is vocab, and you're just going to need to work on that and try and remember what those mean. Hopefully as you get through the homework that you'll be able to get it. If not, spend a little time on the notation and the vocab, okay? So this unit will be exploring statistics and probability. Believe it or not, the majority of statistics is counting, just adding things together, counting how many there are. There really won't be any multiplication, division, subtraction, not even just subtraction, no exponents. It's very simple mathematically, but again, you have to work on that vocab that we're covering. When we do probability, we can like flip coins, draw marbles, roll dice, things like that, okay? And the main thing that we're covering here is called sets, okay? A set is a collection of objects in an element of that set, okay? Each object is an element of that set. So a set, like I said, is a collection of objects. It can be a list of numbers. It could be a list of colors. It could be a list of students in our class. It could be a list of outcomes like heads or tails. So there's lots of different ways, different sets that you could come up with. But the way we do it is this notation. We use these curly brackets. And then like here's some examples of where you would write down your answers. So if we have a die has 6 sides, right? And 1, 2, 3, 4, 5, 6. See, these are some of those sets. So a set could be 1, 3, and 5, like the odds of a die. It could be 4, 5, and 6. That's like the larger numbers, like the larger half of the numbers. Another set could be 3 and 5 or 6. Okay, so sets is just a list of objects or outcomes. Okay, so make sure when you do it, include a bracket for each set or outcomes as we go along, okay? A universal set is basically all possible outcomes. So for a die, a 6-sided die, we have 1, 2, 3, 4, 5, and 6. The notation for that is a capital U for universal set, okay? All right. So a set is just a collection of numbers or shapes or letters, people, okay, it could be anything. And then universal set is all possible outcomes. So like the universal set of people in the world would just be like every single person. And that would be really hard to write down. But that could be like another universal set. Okay, subset. A subset is something that's part of a bigger set. So, for example, our class is a subset of Westlake. Okay, you are all part of Westlake. Okay, so you are a subset of Westlake. You're also a subset of Saratoga Springs. At least you're in Saratoga Springs when we're in class. Okay, so you're a subset of Saratoga Springs. You're a subset of Utah. Okay, all the people in Utah, you're a subset of Utah. Okay, so a subset is something that's part of a bigger set. Right? So here's kind of like the definition. If we had C as a set, C is a subset of A if every element or every part of C is also part of A. Here's the symbol that we use. It's like a U on its side. Okay. And this is the types of problems that you'll run into. So is C a subset of A? That's what that means. Is C a subset of A? And we'd say yes or no. Well, let's look at our sets. C is 3 and 5, and A is 1, 3, and 5. So is all of C in A? Yeah, because 3 and 5 is also in A. So we'd say yes. 3 and 5 are both in A. Okay, what about the next one? Is B a subset of A? Is all of B inside of A? It's not, because 4 and 6 are not in A. So we'd say no. We could say 4 and 6 are not in A. Okay? If we were to like sketch a Venn diagram of this, like another way to represent this would be like if we wanted to use this example, this is saying that C is a subset of A. So all of C is in A. All right? All right, next we have is union. Union, if you think of union like a union, somebody kind of talked about like the Civil War. Like the union is like a group of people with this common goal, or like a credit union. A lot of people will put their money in the credit union and use that to kind of help get like better interests or rent or borrow money, things like that. So a credit union, a union, like a marriage is kind of like a union. You bring two people together, bring their families together, okay? So a union, we take all of A and, I guess we combine all of the sets that are involved. So here's like an example. What is the union of A and B? Well, A, if we look at that, is 1, 3, and 5, and B is 4, 5, and 6. So we will take all of A and all of B and put it in the same set. So here we would have 1, 3, 4, 5, and 6. Okay, we don't double count the 5. It's kind of like if you are in my class for our modern math, and I ask anyone in the class, like, how many of you are in Schmolke's English class? And a few of those would raise their hands, okay? If we wanted to union or bring them together, take all of the students from his class and from our class, we wouldn't have 2 of, say, AJ, okay? AJ's in both of those classes, but we don't have 2 AJs, if that makes sense. So we don't double count as we do the union, okay? What's the union of C and D? So C is 3 and 5, and D is 6, so we would just have 3, 5, and 6. So sometimes you won't have the option to even double count, but we don't want to double count. Okay, so if we want to do a sketch of what this looks like, so maybe like for our first example, this could be A, and this is B. If we wanted to sketch it, the union of A and B would be like all of A, and it would be all of B. You could put numbers in there as well if you wanted to, but I just wanted to make sure you realize like kind of what this looks like if we did like a little Venn diagram. Okay? All right, and last thing is intersection. So intersection, if you think of like 2 roads intersecting, when those roads intersect, they're like sharing the same road, okay? So the intersection of 2 sets are the numbers that they have in common, what they're sharing, okay? So its symbol looks like an upside down U. And if we did the intersection of A and C, so we would look at A and C together and say, well, what do they have in common? A and C both have 3 and 5. So that would be the intersection. Intersection of A and C would be 3, 5. Okay? If we do the intersection of A and D, What do they have in common? Well, they don't have anything in common. So what we would do is we would do our brackets, and we would just leave it empty. Really need to work on my brackets, okay? This is when there's nothing in there, sometimes we call it the empty set. Or the null set. But anyways, empty set I think is more common for me. All right, if we were to sketch and see what that looks like, if we took A and we took B, generic example, their intersection would be what they have in common. So this would be like this part. Okay? All right, so let's just do a couple examples with what we covered. Just a reminder, set is just a collection of objects or numbers, shapes, letters, okay, outcomes. Universal set is all possible outcomes. So like for a die, it's 1, 2, 3, 4, 5, 6. A subset is something is a subset if all of that subset is part of that bigger set. Okay, so like our class is a subset of Westlake. And union, you bring it all together. We just don't double count. And then intersection is what they have in common. Okay. All right, so let's talk about universal sets. Can we write down some universal sets? So if we toss a coin, what are the outcomes? What could happen? Well, we could have heads and we could have tails. Okay, if we have one die and we're flipping it, those are your two choices. If we roll a 6-sided die, we kind of already did that. That's 1, 2, 3, 4, and 5, and 6. A bag that contains, we're going to actually skip this one. I don't want to get people confused with that, but we'll just talk about those two. All right, so given the following sets, identify the following. So we're given a universal set, and set A and set B. Okay, so we're going to use that information to do some set notation. Okay, so what is the union of A and B? So again, union, we take all of A and we take all of B. So we have 1, we'll have 2, we'll have 3, 4, 5, 7, and 9. So 1, 2, 3, 4, 5, 7, and 9. Okay. And then, again, we don't double count. So like we had 2 1s and 2 3s and 2 5s, but we wouldn't write them twice. Intersection. So what do they have in common? Those are the ones that we had that were 1, 3, and 5. So they both have 1, they both have 3, and they both have 5. Okay, next is B a subset of A. So is all of B also in A? No. Okay, and why not? Well, 2 is not in A, 4 is not in A. So 2 and 4 are not in A. Okay, is B a subset of the universal set? So is all of B also in the universal set? Yeah, you bet. Okay, 1's in there, 2's in there, 3's in there, 4's in there, 5's in there. Okay, all of B is in U, the universal set. Okay, so why don't you pause and give, actually we'll talk about this first, and then I want you to try those last examples, and then you'll be set to go. So it says, given a 10-sided die, identify the following sets. So given already, we wouldn't even need to have that known, because we know that a 10-sided die has 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we have our universal set, and then from that we want to write down these 4 other sets, A, B, C, and D. So sets can be written as like almost like words, okay? But we can also translate that into us using set notation. So even numbers are like 2, 4, 6, 8, and 10. Odd numbers, look at D. Since we're already kind of doing that same sort of thing, we have 1, 3, 5, 7, and 9. Prime numbers, okay, so maybe a little review on prime numbers. Prime numbers are things that can be divided by itself and 1, and they have to be unique. So 1 is not prime because it can only be divided by one thing. Prime numbers can only be divided by 2 things, 1 in itself. So prime numbers here would be 2, 3, 5, and 7. Okay? Multiples of 4 are just counting by 4s. So we have 4, we have 8. Those are your choices. Okay? Okay, so why don't you try and see if you can use that information to answer the following questions. Beep, pause. All right, so hopefully you gave that a try. C union D. So the union of C and D. So we're going to take all of C and all of D. We just don't want to double count. So it's going to be 1, 3, 5. Oops, I missed 4. 1, 3, 4, 5, 7, 8, and 9. Intersection of A and D. So we'll want to do what they have in common. So A and D have nothing in common. A is the evens, B is the odds. So here we would have an example of an empty set. B union D. So we bring them all together. It's a union. Okay. So what would we have? We have all of B and all of D. So that's a big one. We'd have 1, 2, 3. Oops, I missed that one. 1, 2, 3. There's no 4. There's 5. No 6, but we have 7 and 9. If I ever mix one or skip one, sorry. I'm sorry. I'm trying to keep the videos shorter for you guys. All right, intersection of A and C. So what they have in common, A and C both have a 4, and they both have 8. So it'll be 4, 8. Is B a subset of A? No. Okay. 2 is in it, but 3 isn't. 5 isn't, and 7 isn't. Okay. So like the odd ones don't go in A. So no. 3, 5, and 7 are not in A. Is C a subset of A? Is 4 and 8 also in A? Yes. 4 and 8 are both in A. All right. So if you have any questions, please stop by. I'd love to help you out. On the homework, let's talk really quick though. Let's see if I can get that. Hang on one sec. Homework. Since you weren't here and you won't be able to ask me questions, I want to maybe talk about 2 of these. So we talked about like flipping one coin. We did that on our notes, heads and tails. But what if we flip 2 coins? So if we flip 2 coins and we end up having like 2 heads, so that would be like one outcome. We could have head, head, HH. Okay. What are some of the other options besides heads, heads? Hint, there's going to be 3 others. Okay. And we only use the commas for when we're trying to separate the outcomes. So don't do H, comma H, because then it's looking like you're doing just H as one of your outcomes. Okay. And then the other thing we want to talk about, we already kind of talked about that, is our class a subset? Explain. So we talked about that. So come up with something, maybe something unique. Is our class a subset of something bigger? Okay? All right. Good luck, guys. We'll see you.